I'm going to be working out problem number 2, question 2, from the 2016 Level 2 Algebra NCEA exam. I did number 1 in a previous video, and so now I'm just going to work through number 2, question by question, and see how we do. And I'd appreciate any comments that you have, because the answers officially haven't come out yet, so people have been posting some good questions. So here we go. Let's get started. All right, this first bit, find the discriminant of the quadratic equation x squared equals 10x plus 3. And of course, the discriminant, when we have a quadratic, I'll just write it right here, when we have it in the form ax squared plus bx plus c equals 0, and we have the lovely quadratic formula, which of course is x equals that lovely equation right there. The discriminant is what's under the radical there. So the discriminant, which is commonly shown by a triangle there, the discriminant is just b squared minus 4ac, where this is a, b, and c. And we should know that by now, maybe. First of all, we rearrange this equation so it's set to 0. So that means this is x squared minus 10x minus 3 equals 0. Sorry about this paper, it's a bit dirty. Okay, so we've got a is our coefficient here. A is positive 1, b is negative 10, and c is negative 3. And that is what we substitute into our discriminant variables right here. And we get the discriminant equals, don't forget to put brackets around the b, so negative 10 squared minus 4 times 1 times negative 3. And this part here could get kind of confusing for some people because of all the negatives, but so let's try not to make any mistakes here. Negative 10 squared, of course, is 100. Now this is negative 4 times 1 times negative 3, which equals a positive 12. And we get the discriminant equaling 100 plus 12 is 112, correct? I think so. Hope I didn't make any mistakes there. All right. Okay, next one. It wouldn't be a level 2 algebra exam unless there was some log simplifying. Would there be? Well, let's just work this problem out, I guess, piece by piece. Multiplying 4 times a log is the same as taking u to the 3.
All right, I'm going to take over here because I made a bit of a mistake. Now in this problem, it's a simplifying one, and how I'm going to change the numerator right here is that u to the power of 3, that exponent 3 is going to get multiplied to that 4, making it 12 times the log of u. Now we're still dividing that by the log of u. So what I have up in that bubble there, which is 12 log u divided by log u, those logs are going to cancel out. They're going to cross-cancel just as if I were cross-canceling two factors of 5 or whatever. So what I'm left with in my end problem is actually just 12. Now, I have this covered up because I made the mistake of taking that 4 log u and taking that 4 and putting it to the power of u to the 3, which was a mistake, and that's why I'm correcting this now. So our final answer on this one is actually 12, not my previous one. Sorry about that.
All right, moving on. Speaking of logs, this is where we're going to use logs to solve for a variable. Okay, so this is a classic problem here. These are on almost every single exam in algebra. So they give us a basic formula here. Marie buys a new car for $24,990. It decreases continuously by 12% each year. Let's just look at this decreasing continuously. What does that mean right here? A 12% decrease means we're taking it 100% minus 12% equals 88%, which equals 0.88 as a decimal. And that's the number that we want to work with. That's a little number knowledge there. Okay, so that's going to represent the rate. That's going to represent that R right there. The value of the car P 2 years after she first bought it can be modeled by this function here. How long will it take for the value of the car to halve? Okay, so we've got, here's what we're looking at here. We've got the original price of the car, $24,990, times the rate of decrease, which is 88%, And how long will it take? That means t equals what? Okay, we're solving for t, which is why we're going to be using logs. And how long will it take to have? Well, the new price is going to be half of 24,990, which, if I did my math correct, is 12,450. Okay? So, yeah, this is, I guess, kind of a long step, because some people just go, well, to solve this log equation, the first thing I'm going to do is divide 12,450 divided by 24,990, and I'm slowly working this out, 0.88 to the power of t. And of course I'm going to get a half right here, which is where some people start with the equation, and that's fine. I mean, if you were able to just get it straight from here and write it like that, that'd be fine. That fraction's kind of bugging me. I'm just going to write it as 0.5 if that's okay. I'm just going to write that as there. That's better. Now here's where we use logarithms. We use logarithms when we're solving for a variable, and this is not going to be a power of 0.88. And so I take the log of both sides and divide by this log 0.88. But what I teach is I just teach it like, if you want to solve directly for t, it's just going to be the logarithm of 0.5 divided by the log of 0.88. And again, this is kind of a shortcut way. I'm not really going into solving log equations, and I'm just assuming that, you know, we can solve these types of equations. And I get 5.42, I think my answer is in years. Is it in years? Yes. Okay, 5.42 years. You know, I don't know how exact they want it here. We could multiply 0.42 times 60 if we wanted to, and say that's about 5 years. I think it comes out to about 5 months. 5 years, 5 months. That sounds about right. Okay, so just nothing too tricky there, really. All right, let's move on. All right, now these next two questions I actually like. I'm going to admit that. This one, fairly straightforward. Solve the equation. If we just write this in index form, so log base 8x equals 2/3. That's the same as saying that 8 is the base, 2/3 is the exponent, and what does that equal? That equals x. So if we can convert log form to index form, we're sweet. Okay, and we can do 8 2/3. We can do that on our calculator if you want to as an exponent, or we just know that, you know, 2 times 2 times 2 equals 8, and 2 cubed equals 8. And what's 2/3 of the way there? What's 8 to the power of 2/3 means this right here. What's 2/3 of the way there when you're timesing by 2 to get to 8? It's 4. So x equals 4. And of course, we've got calculators, and you can just raise that to the power. So let's move on. All right, now you're going to see this creep up again in this problem right here. That's why I like this. Okay, this right here, this looks really hard, first of all. This looks hard, but really, it's a quadratic in disguise. It's a quadratic in disguise. And if I said, let some number, I'm going to say u, let u equal that log 8x. And then all of a sudden, it'll look for a quadratic. So just work with me on this. Let u equal log 8x. Okay, and then I'm going to solve for u, and then I'm going to solve for x, and then everyone's happy. All right, so if I do that, this equation becomes 6u squared plus 2u minus 4 equals 0. All right, now I can just solve that quadratic any way I want. Okay, well, first of all, this is kind of annoying because I think it's got a common factor of 2. It does, so I factor out a 2. Okay, and I get that. Now I can divide both sides by 2, and I get a much simpler equation of that guy right there. So for this quadratic, we can solve it with the graphics calculator. We can solve it with the quadratic formula. I factorized it. When you do factorize it, it comes out to, and I know this is shortcut method, but when I do factorize it, I get this expression right here. Okay. Now, I've already done this in my previous video with question number 1 on how to factorize a quadratic when that coefficient is more than 1. Okay, so warning, shortcut method here. So I solve for u. Well, using zero product property, well, u right here is going to equal -1. Okay, that's great. And u right here, if we can't tell by heart, this factor has to equal 0 as well. 3u minus 2 equals 0. So 3u equals 2. So u equals 2 divided by 3, or 2/3. Okay, so cool. That's pretty good. All right, now what I do, go back up to here and see if I can solve for x, which I think I will be able to. Let's do this first one. If u equals 2/3, then 2/3 equals log 8x. Well, okay, this is looking pretty familiar, isn't it? It's the same problem. I can do it again if I want to, but it's x to the 2/3. Sorry, 8 to the 2/3 equals x. It's there. There it is again. So, save some time. X equals 4. Done. What about the other one? Don't think I'm going to get anywhere with the other one, but to prove it, if u equals -1, -1 equals log 8x. So that means 8 to the -1. 8 to the -1 equals x. Oh, I am going to get somewhere. That's okay. 8 to the -1 equals x. And if we know our negative exponents, 8 to the -1 is 1/8. So how are those solutions? Let's work on this last problem here, which in my opinion is probably the hardest problem on the entire test. Okay, so let's get into it. This could take a while, but I'll try to do it as clearly as I can. So we've got this garden here, triangular garden has sides. I'm just going to work through it as I read the problem. Triangular garden has sides with the length in the ratio 3, 4, 5. Okay, and I'm assuming that it's a right triangle. They could have told us that. But if this is the ratio, then the hypotenuse is going to be the longest side. Okay, so that guy is going to be the 5x there. This will be the 4x, and this will be the 3x. Okay, so let's just go with that for now. The path is 1 meter wide. Okay, and at each corner of the garden, the path is a sector, which is a part of a circle, and it just bends around with the radius of 1 meter. Now this is the part that's interesting. The difference between twice the total area of the path and the area of the garden is 2 pi meters squared. And then finally it asks us to find the length of the longest side of the garden, which is that hypotenuse right there. And that length is going to be, so I'm going to solve for x somehow, and then I'm going to substitute that x in for 5x and work that out. Okay, well what the heck is going on here? Let's first of all, how I looked at this is I wanted to figure out what these angles were in these sectors right away. Okay, so if that's 90, that's 90, and we're going to assume that's 90. Well, that's got to be 90 as well. Okay, because of angles around a point equal 360. And what I did was this. Excuse me. I looked at these two sections here. Okay, those two sectors, and I know that these two angles of the right triangle have to add to 90 because the angles in a triangle add to 180. So what I did was, with these two angles here, that guy and that guy, I know that there's a 360 here and there's a 360 here. So all of these angles in here have to add up to 720. Okay, so work with me on this. First of all, 720, and how I'm going to find these two angles. I won't know what each one of them is yet. Okay, so how I'm going to find these two angles is all of it combined is 720, and I'm going to subtract 5 lots of 90. 5 lots of 90, and that's going to give me 270 degrees. Now, why you're saying 5 lots of 90? Because I have 1, 2, 3, 4, and these two inside have to add to 90 as well. Okay, so what I did was I figured, okay, the area of the sectors, it actually equals one whole circle. Area of the sectors. Because what I have here is I've got 90 degrees here plus 270. And 90 plus 270 equals 360. So I've got one full circle. These here make one full circle. Okay, so if that's the case, and it's got a radius of 1 meter, then my area of the circle is going to be pi times radius squared, and pi times 1 squared is just going to be pi. Okay, so that's my area for the circle bits. Now again, that skill in itself, figuring out the angles of those sectors. I didn't figure out the individual angles, although I could have using trigonometry. I just figured out that these three added up to a full circle. There probably is other ways of figuring that out. That's just the way that I looked at it. Next bit I looked at was what's the area of the garden. I don't know what that is yet. I mean the actual number yet, but I'm just going to go, okay, area of the garden is base times height divided by 2, because that's what a triangle is. Base times height divided by 2 gives me 12x squared on top divided by 2. So the area of my triangle, I'm running out of room here, sorry about that. It's because I have a portrait paper and a landscape screen, so this happens. I get 6x squared for the area of the triangular garden there. Great. All right, now I'm going to translate this statement here into a math equation here. So twice the total area of the path. I don't know what that is yet. Twice the total area of the path. Oh, sorry, I forgot to do that. The difference between twice the total area of the path and the area of the garden is 2 pi. So the difference is take away. The area of the garden is 6x squared. And the difference between those two is going to equal 2 pi. Okay. Well, let's get the path part without the circular sections first. The path part here, the rectangular parts. So what I did to get the area of the path, this rectangle here is 4x by 1, and this rectangle is 3x by 1, and this is 5x by 1. All right? So the area of the path is going to be 3 rectangles. All right? This one is 3x times 1, which is 3x, plus this rectangle is 4x times 1, which is 4x, plus this rectangle is 5x by 1. Those are its dimensions. So this is the area of the green bit, or orange bit, sorry. All right, so the path also includes the circular parts, and that's going to be plus pi. Okay? Hope that makes sense. So when I simplify that part up around there, it gives me, I think it gives me 12x plus pi. Okay? All right, now for the interesting bit. So since this is the area of the path, I'm going to take that expression and substitute that in for p. Okay? So when I do that, it's going to be 2 times the area of the path, which is 12x plus pi, close brackets, minus the area of the garden equals 2 pi. And now I'm going to simplify here. I'm going to expand this 2 through, and I get 24x plus 2 pi minus 6x squared equals 2 pi. And you can see what's happening here. I'm running out of room. Sorry about that. I've got 2 pi on both sides of the equation, so I'm just going to subtract that from both sides. And I get 24x minus 6x squared equals 0. And all of a sudden I have solving a quadratic. And this one's got a common factor of 6x that I can factorize out. 6x times 4 is 24x, and this gives me an x because 6x times negative x is negative 6 squared, close brackets, equals 0. I'll get 2 solutions. This solution for x gives me 0, and this solution of x gives me 4. Whoops, sorry about that. Okay, so yep, 2 solutions there. That's great. And my overall question, I want to find the length of the longest side of the garden, which is 5x. Well, if x equals 4 and the longest side is 5x, well, you guess what it's going to be. It's going to be 20, isn't it? So we're going to say that the longest side of that garden is 5 times 4, which is 20 meters. Okay, and that is that problem right there, which was a doozy. And if you got that one, well done. Okay, so that's question 2. Thanks for watching. Any questions or comments, please just write them down below. Okay, happy to listen. Thanks for